Okay, so we're looking at this question here. It says Calendula Biscuits Limited faces the following profit function. We've got this profit function Q and A here. This is our profit function where Q is thousands of packets produced and sold per month, and A is advertising expenditure in thousands per month. Number one, derive both first order conditions by taking the partial derivatives of pi with respect to Q and A and setting each equal to 0. All right, colleagues, so this is partial differentiation here. Let me just write this here. We have pi hidden here. Q A equals 120 Q minus 3 Q squared plus 60A minus 2A squared minus QA minus 800. Yes, so we have to get the first order derivatives. Basically, we're going to have to partially derive this profit function with respect to Q and with respect to A, and setting our derivatives equal to 0. So first things first, we're going to partially derive our profit function with respect to Q. Okay, meaning when deriving, we're only focusing on numbers where there is a Q. Okay, so like this 120Q, when we derive it, it becomes 120 minus this 3Q squared. When we derive it, it becomes 6Q. This 68 hasn't got a Q, so we ignore it. This negative 2A squared doesn't have a Q, we ignore it. This QA here, when we derive it, right, since this is Q to the power 1, so it's like a deriving Q to the power 1, A to the power 1. So when you derive this one here, it becomes A minus A, like this. Yes. Any questions, colleagues? Are we okay with our derivatives? All right, so you set this equal to 0. Okay, set it equal to 0. Next, we'll derive our profit function with respect to A now. Meaning any number or variable that doesn't have an A, we ignore. So we ignore this 120Q, this 3Q squared, we ignore it. This 60A, when we derive it, it becomes 60. Minus this 2A squared becomes 4A. 60 minus 4A. Minus this QA, when we derive it, becomes minus Q. Equal to 0. Okay. Yes, colleagues. Any questions before we go to part 2? Part 1, the verse has to derive both first order conditions and set each of them equal to 0. Then part 2, solve the system of first order conditions to find the optimal output Q and the optimal advertising spending A. Show all your workings. All right, so colleagues, here they're asking us to find the values of thing Q and A. So here we need to use simultaneous equations. Okay. So this expression here, okay, if we write it down here, 120 minus 6Q minus A equals 0. Okay, so I want to form a system of simultaneous equations. All right. So colleagues, here what we can do, this negative 6Q, we can take it over this side. This negative A, we can take it over that side. So that our equation now becomes 120 equals 6Q plus A. And this is equation 1. Yes. Any questions? We also do to the same to this equation here. 60 minus 40A or 4A minus Q equals 0. All right. So this negative 4A, we can take it over this side, and this negative Q, we can take it also over that side. Okay. So that we have 60 equals 4A plus Q as equation 2. Okay, I hope we're all okay up to this point here. So now we have to solve this simultaneous equation here. Okay, we solve this simultaneous equation here. So we can solve by elimination or substitution. I usually like to use substitution. Okay, so I like to use substitution. So if we look at this equation 1 here, okay, let me put it here. 120 equals 6Q plus A. We can make A the subject of the formula. Okay, we can say A equals 120 minus 6Q. Okay, because this 6Q, we've taken it over this side, it becomes negative. Okay, and we can say substitute this into equation 2. Okay, this substitute into equation 2. So where there is A, we're going to substitute it with this expression here. All right. So in equation 2, we're going to have 60 minus 4A plus Q. So we're going to substitute the A with 120 minus 6Q. So we're going to have 4, open brackets, 120 minus 6Q plus Q. Okay, so we solve. So we're going to say here 60 equals 4 times 120, that is 480. Okay, we're distributing this for 4 times 120, that is 480. 4 times negative 6, that is negative 24q, plus q. Okay. So we're going to say we like terms here, negative 24q plus q, that will give us negative 23q. This 480 has to go over the equal sign here. So we have 60 minus 480 equals negative 24q plus q. So 60 minus 480, negative 420. Because negative 24 plus q, that's negative 23q. So to find the value of q, divide both sides by negative 23. Okay. So 420 divided by 23, I get q equals 18.26. Okay. Any questions, colleagues? That's our value of q. Now we can find a. Okay. Remember, a equals 120 minus 6q. So you say a equals 120 minus 6q. So 120 minus 6 times 18.26. Okay, 6 times 18.26, that gives us 120. So 6 times 18.26, that gives you 109.56. Okay. 120 minus 109.56, A equals 10.44. Okay. Yes. Any questions, colleagues? We found our values of Q and A. Part 3. Calculate the maximum profit at the optimal values. So these values of Q and A, we're going to take them back to the profit function here. Each is a big profit function. Yes. So let me erase this part here. Hundred and 20, open brackets, Q is 18.26, minus 3 times 18.26 squared plus 60, A is 10.44, 60 times 10.44 minus 2 times 10.44 squared minus QA, so minus 18.26 times 10.44 minus 800. Yes, let's get our calculators. My calculator. 120 multiplied by, so I'm just putting the whole tabulation in my calculator, okay, so that you just get one answer, because it's a big, this is a big operation here. 3 times 18.26 squared plus 60 multiplied by 10.44 minus 2 times 10.44 squared 10.44 squared minus 18.26 multiplied by 10.44 minus 800. We get 608.69. 608.69. That is the profit that we're going to get, the optimal profit. Yes. Any questions, colleagues?